Thank you very much. It's really a great pleasure to be here. Over the last decade or so, I've been really focused on the potential implications of artificial intelligence and robotics. Let me just grab it. I've been focused on the potential implications of technologies like robotics and artificial intelligence. And I've really come around to the view that we could well be on the leading edge of a major disruption. And I think it's a disruption that's going to completely redefine the way businesses compete. And it's also going to put a lot of stress on both society and on the economy. And the central issue that I've really focused on is the fact that robots and smart algorithms and computers are increasingly going to substitute for human workers. They're going to take over more and more of the work that's now being done in the economy, and I think that ultimately that could lead to some real challenges for us. Now, during the course of my research, I've had a chance to talk to a lot of people that are really on the leading edge of these technologies. In other words, people that are really innovating in robotics and AI. And what I found is that, at least among those technical people, there is something of an emerging consensus that we really are headed toward a disruption. Maybe even we're ready to enter an entirely new era, a time when perhaps things are not going to work according to the same rules as they have in the past. But at the same time, there's a lot of skepticism out there about that whole idea that this time is maybe really different. And I think it's probably fair to say that economists generally tend to be quite skeptical of it. And that is largely based on the historical record. It turns out that this concern, this fear that machines might displace a lot of people and maybe lead to unemployment, it goes back at least 200 years to the Luddite revolts in England, and since then it's come up again and again. I'm going to guess that most of you have probably never heard of the Triple Revolution report. But this was actually a very prominent report. It was put together by a brilliant group of people. It actually included 2 Nobel laureates. And this report was presented to the President of the United States, and it argued that the U.S. was on the brink of social and economic upheaval because industrial automation was going to put millions and millions of people out of work. And this report said if the government didn't do something right away, there was going to be chaos. Now, that report was given to President Lyndon Johnson in March of 1964, so that's now over 50 years ago. And of course, that hasn't really happened. And that's kind of been the story again and again, is that people have worried about this, the alarm has been raised, but it's always turned out to be a false alarm. You know, the economy has adjusted, new jobs have been created, people have found new things to do. And so it's very reasonable to be skeptical, but I do think that we are probably finally at the point where the technology is finally here and that some of these fears are likely to be realized. So what I want to do is begin by telling you why I think information technology is really different. What is so different about it relative to the technologies that have caused disruptions in the past? And I would point to 3 fundamental things. The first thing is that, of course, we have had this ongoing process of exponential acceleration. I think many of you have heard of Moore's Law, of course, or this idea that every 2 years or so, computers roughly double in power, but it's actually much more broad-based than that. It extends, for example, to communications bandwidth. It extends, in many cases, to software, where we've seen an acceleration even more rapid than Moore's Law would imply. But the other key thing to understand is that this acceleration has now been going on for a long time. It's been going on for decades. If you measure from the late 1950s, when the first integrated circuits were fabricated, we've seen around 30 doublings in computing power since then, which is just an amazing number of times to take any number and double it. You can kind of imagine that by thinking about what would happen if you got into your car and you started driving very slowly at 5 miles per hour and then gradually double your speed to 10, to 20, to 40. If you do that just a handful of times, you'll need a faster car on a racetrack. If you could do that 30 times, you'd be some kind of science fiction spaceship. You'd be traveling at millions of miles per hour. You'd be able to get to another planet in just a few minutes. And that's really where we are in terms of today's technology, you know, relative to where we began. And because things are now moving at such a rapid rate, and because things are going to continue to accelerate from this point, we're going to see things over the next years and decades that really astonish us, you know, things that in terms of technology we're probably not quite prepared to see. The second crucial thing is that is that the machines are beginning to think in a limited sense. By this, I don't mean science fiction artificial intelligence, but rather that machines are making decisions. They're solving problems, and most importantly, they're learning. In fact, if there's one technology that is really central to this and has become the driving force behind it, it's machine learning, which is just becoming this incredibly broad-based, disruptive, powerful technology. One of the best examples I've seen of that recently was what Google's DeepMind division did with its AlphaGo system. This is the system that won at the ancient game of Go. Now, if you know anything about Go, there are two things that to me really stand out. One is that as you're playing the game is almost incomprehensibly complex. There are more possible permutations for the board to be in than there are atoms in the universe. So what that means is that you're never going to be able to build a computer to win at the game of Go using the same approach that was used with chess, which is just to throw brute force computational power at the problem and let the computer compute all the possibilities. The game of Go is too complex for that. You could never build a computer that could do that. So it takes a much more sophisticated human thinking-like approach. The second thing that really stands out to me is that if you were to interview one of the championship Go players in the world, these people very often can't even really explain what's going through their mind as they play the game. They say that very often it's just kind of an intuitive feeling that they get that they should make a particular move in order to win at the game. And so if you imagine that you were a computer programmer interviewing one of these people, trying to understand what they're doing so that you could put that into computer code, you wouldn't even know where to begin. So given those facts about the game of Go, it would seem to me that playing this game at a championship level ought to be something that's safe for people. It should not be something that a computer can do. It should not be something that we can automate. And yet, Google has already built a system that not only taught itself to play this game, but then within short order, it was able to beat virtually any human being in the world. So what that says is that a lot of our assumptions about which jobs are safe for people and can't be automated, can't be taken over by technology, a lot of those assumptions are going to turn out to be wrong because this technology is going to turn out to be extraordinarily powerful. The third thing that's really critical is that information technology and increasingly artificial intelligence is really becoming a general purpose technology. And what I mean by this is just that it's going to be everywhere. It's going to invade the whole economy, every industry, every business, every employment sector. It's going to be everywhere. A number of people have compared information technology to electricity. And it's true that information technology and artificial intelligence are becoming like a utility. Almost like electricity. You would never ask what industries are most impacted by electricity. That seems almost like a silly question. I mean, everything, every business, every industry is dependent on electricity. And the same is going to be true of artificial intelligence. So it's going to scale across everything. It's going to invade every industry. And one of the implications of that is that it's going to make everything less labor intensive because it's going to bring to bear this ability to basically to think, to solve problems, to make decisions, and to learn. And that's likely to displace a lot of jobs, especially jobs done by people that are doing things that are more routine and repetitive and predictable. So it does have the potential to be very, very disruptive. One point that's often made by people who are perhaps a bit skeptical of all of this is that of course, many jobs will be destroyed by technology. Those jobs will disappear. But of course, there are also going to be entirely new things created, right? There'll be jobs created in the future that today we can't even imagine. And that's definitely true. In fact, you can already think of jobs that exist today that not too long ago we wouldn't have been able to anticipate. Things like website designers, social media marketers, data scientists. These are all new kinds of work. But what I'm showing on this particular chart, if you look at the bar chart on the right, it shows you that while these new kinds of work do exist, they really aren't a substantial fraction of employment. It turns out that in the United States, about 90% of our workforce is engaged in occupations that existed 100 years ago. So, it's things like driving vehicles, preparing and serving food, working in offices, doing routine things, working in factories and warehouses, working in healthcare. These are all occupations that someone in the year 1915, say, would have been quite familiar with. So the point here is that while new things are going to be created, there may not be enough of those opportunities to absorb all of the workers in traditional occupations that are sure to be disrupted in the coming years and decades. Just to take one example, think about the impact of self-driving vehicles, cars and trucks. Just that one single innovation could potentially eliminate millions and millions, tens of millions of jobs. And of course, it's not going to be just self-driving vehicles. It's also going to be fast food robots and improved robots in retail and factories and warehouses. And it's going to be automation in many, many white-collar areas. So there are going to be millions and millions of jobs at risk there. And the question is, well, there will be new things that are created. Will there be enough? And secondly, is there going to be a skill mismatch problem in the sense that, well, there may be new jobs created, but will the person that's driving the taxi or working at the McDonald's, will they really have the skills and the capability to move into one of those new jobs? Or maybe those jobs will really require high levels of education and skill. So again, this, I think, points to a potential challenge that we could face over the next 10 to 20 years. Let me show you a couple of graphs of economic data taken from the United States primarily that I think demonstrate that technology is already having an impact on the job market. Now, what you see here is a comparison of productivity and compensation or incomes for average people in the United States. Now, productivity is a measure of efficiency. It's basically equal to what we produce, the value of what we produce divided by the number of hours that it takes to produce it. And what you see in this graph is that right up until the mid-1970s, these two lines move together perfectly. They're perfectly correlated. And that's exactly the way things are supposed to work. The idea is that technological progress increases productivity. Therefore, workers can produce more. They become more efficient, more effective, and therefore they should be paid more. They become more valuable. And that's just what happened right up until 1973 or so. But at that point, you see these two lines diverge. They decouple. And compensation or incomes have basically stagnated. They're pretty much flat, where productivity has continued its increase. And you see this big gap opening up. Now, I think that one of the things that's causing that to happen, there are a number of forces in play here, but one of the things that's most important, I think, is that the nature of our technology is shifting, where once machines were tools used by workers and therefore made those workers more valuable, increasingly machines are substituting for workers. And instead of making workers more valuable, the machines are displacing the workers and maybe making them less valuable. And I think that this is one of the reasons that you see this big gap opening up, and it's one of the reasons that we've seen income stagnate in the United States. And you see also the same kind of graph there for the United Kingdom in the top left, and you see basically the same shape there. I also think that this graph probably to a large extent explains some of the political disruption that we've seen. If you want to understand why Donald Trump is the president of the United States, this graph to some extent explains that, because a lot of people, a lot of voters in the industrial Midwest are very unhappy because they feel they've been left behind, that they're no longer participating in progress. And I think that this graph shows quite vividly that that's true. They are in fact being left behind. So this is a real problem that's already created disruption for us. Here's another graph showing what job creation looks like in the United States. You can see it looks almost like a declining staircase. Every decade just about has produced fewer new jobs than the preceding decade in percentage terms. So I think that, again, this is a sign that some kind of a structural change is happening in the economy. And I think that it's happening almost certainly as a result primarily of technology. So let me talk a bit about some of the technologies that are causing all of this to happen. And robots, of course, have been around for a long time. If you had gone into an automotive factory in an advanced country back in the 1980s, you would have already seen these big, powerful industrial robots. So what all this automation means that in developed countries, within manufacturing, all of the truly rote, repetitive assembly line jobs where you just stand there and do the same kinds of thing again and again, those jobs have already disappeared. And the jobs that have been left for people in manufacturing have primarily been those that are unpredictable. Often it's jobs that rely on qualities like visual perception and dexterity. An example of that might be loading and unloading trucks in a factory. That used to be a job that could be done only by people, but that's rapidly changing. And what you see here is a picture of a robot built by a company in Silicon Valley that is specifically designed to move boxes. And you can see that in the picture here, the boxes are not stacked precisely. Some are rotated a little bit. There are gaps between the boxes. The boxes are different shapes and size and colors. Up until recently, only a person would have been able to figure out how to move these boxes. But this company has built a robot, and you can see it looks like a robotic arm with a machine vision camera on the end. This is a robot that can now move these boxes, and eventually this company expects the robot will move about 1 box every second. Now that compares to about 1 box every 6 seconds for a productive worker, a human worker. So you can see how that's going to be a big disruption. Also, this robot will work continuously. It's not going to get tired. It's not going to get injured. And so as this technology becomes more affordable and available and reliable, a lot of companies are going to come to rely on this, and that's going to threaten a lot of jobs. Now, there's quite a conventional way of thinking about this, which says that if you are working on a loading dock, lifting heavy boxes all day, that's not a great job, really. You're likely to injure yourself. If you do that for decades, many people end up disabled. They can't even work at all because this is such a difficult job. So in a sense, if a robot's going to come along and take away this job, we shouldn't be too upset about that. That, in a sense, is a good thing. That's something that we might celebrate. And there is a solution to that, that when a person loses a job like this, we ought to send them back to school, give them some more training. Maybe they end up working in an office, in a safer, more comfortable work environment. That's the way things have always kind of worked in the past. But what I want to show you next is the reason that maybe that's not a sustainable way of viewing this. And this is a graph that is focused on white-collar automation. In other words, computer algorithms that are doing white-collar jobs and more skilled jobs. And what you see on the right is a bar chart showing the number of employees in the corporate finance department in the largest U.S. corporations. And corporate finance is jobs like accounting, accounts payable and receivable, financial planning, and so forth. And if you look at that chart, you can see that about 40% of those jobs have disappeared in the last 10 years or so. And that's happening largely as a result of smart software, which is taking on more and more of this work. And there are many other examples we can give. For example, lawyers are being impacted by smart algorithms that can review documents and figure out if they're relevant to a court case. There are also sophisticated systems that can evaluate contracts. Journalism, for example, is another example. There are systems that can tap into a stream of data, analyze that data, and then automatically generate a news story. And those stories are published online or in newspapers, and you can read one of those articles, and it won't be immediately obvious to you that it was written by a machine and not a human journalist. So this is becoming very disruptive, and I think that what it leads to is a world where almost any kind of knowledge work, any kind of white-collar work that involves sitting in front of a computer, doing predictable things, generating the same report again and again, or doing the same kind of analysis, all of that is going to be highly subject to automation. And these, of course, are skilled people in many cases, people that have gone to university. And so if this idea that we can just educate people more and more no longer becomes sustainable, then we really need to think in a different way, because this is going to be a real challenge for us. Another very important point that I want to make is that all of this has an economic impact. Obviously, if many people in the future are unemployed, that's a big social problem, but it's also an economic problem because the market economy relies on people who can buy the products and services being produced. Businesses have got to have customers with money. If they don't have enough of those customers, then we run the risk of getting into stagnation or even a kind of a downward economic spiral where we just don't have robust economic growth. So the point here is that as these trends accelerate, this could get a bigger and bigger problem, not just for those people that lose their jobs, but really for everyone, for our whole economy. There simply may not be enough demand there to really have vibrant economic growth. So that's an issue that I think needs a lot more thought. I've talked a lot about the negative aspects of this. In other words, the idea that there's going to be a big impact on jobs and so forth. I want to make sure that I at least briefly mentioned the positive side of this. And that comes about because there's going to be enormous progress as a result of all this incredible increase in our ability to compute and solve problems and leverage technologies like artificial intelligence. People have noticed that in the last half century or so, there's been quite limited progress in many areas, and all of the real, true disruptive advances have really been concentrated in communications and in computers. As an example, consider the airline industry. I mean, the airplane that you get on today is really not too different from the one you would have gotten on in the 1970s. So we haven't seen a lot of broad-based technology progress, but I think that's going to change. It's going to change because of all this incredible power that we're going to begin to leverage in all of these other areas. And I want to just mention briefly one example of that in terms of a company that I'm actually involved with, and it's a company called Genesis Systems, and it's focused on atmospheric water generation. In other words, extracting water directly from the air. And that's not actually a new idea. That's how a dehumidifier works. But this company has, utilizing powerful information technology, developed a really revolutionary technology. And we think that we'll be able to deploy within a year or so self-powered units that are able to extract water at industrial scale in some of the most arid regions of the world. For example, in North Africa, in the Middle East, in Australia, maybe some areas of Italy here where you have a real scarcity of water. And of course, that's very disruptive because there are many regions and economies that are really held back by a lack of access to water. And of course, climate change is making that situation dramatically worse. So this is just one example of how all of this powerful information technology is going to begin to play out in many, many areas of the economy in a very disruptive way, and it's going to bring enormous benefits to all of us. And therefore, the last thing that we would ever want to do is to try to stop this progress. We don't want anyone to say, let's not have this progress because jobs will be threatened. So therefore, we need to adapt to it. And that brings me to my final point, which is what can we do about this? And I think that, it's easy to view this in a very utopian way. You can imagine a future where we might all have to work less, where maybe nobody has to do a dangerous job or a really boring job or a job that they hate. People have more time for leisure and for their families and so forth. And I think that that's a great vision. That's something that we should strive for. But at the same time, we have to be realistic, and we have to understand that we're probably going to run into a significant income distribution problem. A lot of people are going to be left behind by this. Their livelihoods and their incomes are going to be threatened. And we're going to have to figure out a solution to that in order to remain socially stable, and also to solve the problem I mentioned earlier of the fact that we really need people with money to spend in order to drive that whole economy. In order to solve that problem, I think ultimately we're going to have to find a way to decouple jobs from incomes. We're going to have to ultimately find a way to make sure that everyone has at least a minimal survivable income, whether they can find a traditional job or not. And I would argue that the best, easiest way to do that is going to be some kind of a universal basic income or guaranteed minimum income. And that is, but no doubt, that remains a very tall order politically. It's a staggering political challenge. There are some small-scale experiments happening throughout the world with basic income. I think that it will still be some time before we're ready to really scale that out and begin to really consider that as a kind of a national solution. But I also think that that's almost inevitable, that will have to happen. As these trends accelerate and as things become more and more unequal, we're going to have to think of unconventional ways to solve this problem, or we're really going to run into some huge difficulties, I think. So my point in coming and talking to all of you and to groups like you, and also in writing about this, is to get you thinking about it. I hope that you will really think about this issue, because I think this is going to be one of the biggest challenges that we face in the coming years and decades. And I hope that as you think about it, talk to others, debate others, that we're going to engage in this global conversation, and from that will emerge some solutions so that we can really build a future and an economy that works for everyone at every level of our society. Thank you very much.
Grazie, Martin Ford. Thank you, Martin. Thanks so much.
Well, thank you very much. Let's connect with our video recorder. Here you can see a map of things Martin Ford told us. New jobs are being created, but you need incentives. And so this is the initial sketch of what we heard. So let me give you the number for questions, 335-7085-439. Now we also have Martin's account, M Ford Future.
Question, because I feel like I need a drink. I need a strong drink after, the idea that you gave us about the future. We heard a lot of talks about the jobless recovery. It's been underway since 2009, 2010. We had in Italy a double recession, and we've lost 1 million jobs during that recession. We are trying to get back to normal level of unemployment. We are still very far. And my first question is, if we look at what happened in the US, currently in the US, the unemployment rate is at historic lows. Is this just about gig jobs, or is it happening something different? Do you feel like that the historic correlation between economic growth and job creation is over? Have we entered a new era? Or we can rely on what's happening in the US and we can still trust that if we get to a decent economic recovery, we will get to new jobs also here in Europe and Italy?
Well, first of all, I would say that relying on what's happening in the US is maybe problematic because what's happening in the US isn't quite as good as what it looks. I mean, we do have a very low unemployment rate, below 5%, but one reality is that a lot of people have completely left the labor force. They've just given up and dropped out of the workforce. So our labor force participation rate, in other words, the number of people that are either working or looking for a job, is actually declined quite dramatically. So, to some extent, that low unemployment rate is less optimistic than it looks. The other point is that while we have been creating jobs that have gotten to that low unemployment rate, there's definitely been a decline in the quality of the jobs. One thing we're feeling very strongly is what's called polarization, which basically means a hollowing out of the job market, and the good, solid middle-class jobs, the kind of jobs that you really want, the ones that provide a good income and vacation and good benefits, those jobs are disappearing. And instead, what you're seeing are lots of low-wage jobs in the service sector. So there are, even in the U.S., there are problems. So, and we've also, of course, noted the jobless recovery is there as well. I mean, I have a graph in my book that you can look at that shows how jobless recoveries in the United States are getting longer and longer. I mean, it takes longer and longer for the economy to get back to where it was, even as it's producing jobs that are, less desirable. So the question is, will Europe finally recover? I mean, it's hard to say. I mean, I think a lot of what happened here is still hangover from the financial crisis, of course. I know that you have a very high level of youth unemployment, but the question is, can the normal process of recovery overcome the other trend, which is the one I talked about, is these technologies are going to get more and more powerful. So I think we'll have to see about that. But I would be cautious at looking at the United States as an example of great optimism in terms of the job market, because there are real challenges there as well.
So in your views, what are the jobs that my sons, for example, should be prepared to if they want to find a decent occupation in the future?
Well, the best advice I can give is that the last thing you want to do is go to school and prepare yourself for a job that's routine and repetitive and predictable. So you don't want to end up any kind of job where you come to work and you do the same thing again and again. And it doesn't matter whether that's a blue-collar job in a factory or sitting in front of a computer doing some kind of knowledge work. So probably the skills that are going to be most important in the future and most valuable are things like creativity, coming up with genuinely new ideas, or the ability to interact with other people in a very sophisticated way. In terms of people that are going to go to university, those are probably the two areas that I would emphasize. There's a third area, and that includes jobs that really require lots of mobility and dexterity in unpredictable environments. And this would be skilled trade jobs, things like plumbers and electricians, which Of course, university-bound students aren't, especially excited for those jobs, but those are the other areas that are probably fairly safe from automation.
In fact, this is one of the first questions that I got from the audience, which will be the truly distinctive skills that won't be reproduced by machines?
Right. I mean, it's creativity, empathy, the ability to work with people, engage with people. But again, we're speaking of the near term. I'm thinking 10, 20 years. I can tell you that there is already research underway into creative algorithms. In my book, I give examples, for example, of algorithms that have successfully written symphonies, original symphonies, painted original works of art, and so forth. So computer algorithms are beginning to exhibit creativity already, and who knows what that's going to look like 20 years from now. So, and the same is true in terms of interpersonal relationships. There are already algorithms that can help with counseling, that provide people assistance with psychological problems and so forth. So you can never say never. I would say that for now, focus on creativity and working with people as two particular areas that seem to be the safest.
Now, in Italy, but in Europe, we are trying to push forward the traditional industry and manufacturing in general to combine with digital, to move into the 4.0 transformation. At the same time, apparently, the companies that are more in trouble and that lay off more are the ones that are laggard in terms of technological transformation. So what should we do? What we are currently doing with the national plan, giving incentives to companies that become more automated, more intelligent, more smart, or try to prevent that and to remain in the old world?
Right. I would never argue for trying to prevent progress and stay in the old world, because what's going to happen is you're going to be outcompeted by other countries, right? And you're going to become irrelevant. So I don't think there's really a choice here. I think that from the business world, you've got to embrace these technologies. You need to obviously retrain or get people, repurpose the workforce so as many people as possible can remain relevant working with these new technologies. But it seems highly likely that that's going to be fewer people. So probably it does mean that there are going to be fewer jobs as these factories and workplaces become more and more automated. And so our challenge is to, as I said, is to find a way to adapt to that so that we can continue to leverage that progress and all of the great things it's going to bring for us. But at the same time, we need to take care of those people that are going to be left behind, or else we're going to have...
Do you think that taxing robots makes sense? Because we are de-taxing companies that buys robots.
Right. I don't advocate specifically taxing robots because, first of all, it's hard to know what a robot is. Very often, as I suggested, what we might call a robot is just software. It's going to be part of the enterprise software in a big company. How would you isolate that and figure out how to tax it? It's too difficult. Also, that would put your country at a disadvantage, right? To another country that doesn't tax robots. But I do think we need to shift our taxation scheme. Right now, we very heavily tax labor, right? We tax workers and labor, and that probably isn't sustainable because there are going to be fewer jobs and fewer incomes. So probably we need to shift to taxing capital more, or business profits more, or more, the wealthiest people who are capturing more and more of the income. We have to tax those more, but more of a simple scheme rather than trying to tax robots, I would say.
Last couple of questions from the audience. First, how do you see the role of public governments in the future in managing this transformation? And second, where do you see the next Silicon Valley in terms of where artificial intelligence is more ahead in terms of innovation, and is there any place outside of the Silicon Valley?
In terms of the role of government, I think it's critical. I mean, the last point I made in my presentation is that I think we have to adapt to this, maybe with something like a basic income. And clearly, I think that calls for a role from government. I mean, I think that there is a space for government and business to collaborate there and to work together. But a big part of that is simply business understanding the reality of this and supporting some of the things that governments are going to have to do, and not always, for example, trying to avoid taxation, trying to either oppose it domestically or escape to another jurisdiction in order to avoid it. I mean, if businesses are going to continue to do that, we're going to end up with kind of a race to the bottom. So I hope that in part because of conversations like this, that attitude will ultimately shift, and there'll come to be an understanding that we need some sort of a solution to this. In terms of the new Silicon Valley, I mean, you know, it looks like in terms of the companies that are really going to control this, it's going to be, for the foreseeable future, the same ones that are on top now. It's going to be Google and Facebook and Amazon, and those companies are becoming incredibly powerful, partly because they have so much money, and partly because, maybe more importantly, because they control so much data. And the access to that enormous quantity of data is one of the biggest inputs to this. It's one of the, you know, the most important aspects of building artificial intelligence. So in terms of other Silicon Valleys emerging, I mean, the other best place to look would be China. I mean, China has certainly got its own ecosphere of incredibly powerful companies that are doing AI, Baidu and Tencent and so forth. So, you know, but part of the story here is I don't think that it's critical that everyone competes directly in creating artificial intelligence. It's important to note that, well, these companies are going to become really powerful, and maybe we do need to regulate that or be concerned about the power that they have. It's also true that this technology will disseminate, and that businesses of all kinds and all sizes are going to have an opportunity to leverage these technologies within their business models. And I think that's going to be the real challenge for you know, businesses of all sizes throughout the world.